Okay, this is TEAS Mock Math version 5. I am going to emphasize certain things to try to keep this short, but give good explanations on the really hard stuff. You may have noticed, hopefully you noticed, that there was a note up here at the top that there are certainly some questions in here that are in their hardest possible version. And you will definitely get questions on your test that are in their hardest version. What I mean with what I said at the top here is more that you wouldn't get them all in their hardest version, all in one test like we see here. So scale-wise, your score on this test is going to be lower than what it would be if you were at your TEAS today taking the math, because I put a lot of sort of worst case scenarios, extra practices. I did that because of who would typically take Mock 5 and where that student would be in their program. So most likely you've done quite a bit with math. You are ready to advance your thought processes. And I essentially wrote this to where you're going to stretch some of your thought processes to their furthest possible limit. But keep in mind that with the real test, you won't get stretched on every question like that. And not every question is hard on this mock, but certainly more of them are in the super advanced category than what you would typically see. I did kind of space this weird, and I did that for my walkthrough part of it. So the ones that have a lot of space, I gave you a lot of space so that you would have your work and then I would have room to do my work, and hopefully you can fit both of those into the space. Some of these I'm going to go over very quickly, and if you have a specific question, and you know, obviously anytime that you get an answer that's wrong, once I've given you the one that's right and you've circled that, you can come back to that when you're done with your mock. Using the right answer, you will most likely figure out where you went wrong, because the right answer is usually the only thing that you need for that. If you don't, and it's not one of the ones I discussed, just send it to me so that we can look at where you're having trouble on that operation. If I explain every one of these, this will be an hour and a half long mock, and I'm shooting for hopefully 30 or 35 minutes, because again, those of you that are taking this particular version are very close to the end. A lot of you are having to move through very quickly, so I'm trying to keep the advanced versions of the mocks short, but not shortchange the explanation on things that I think you still actually may benefit from. The first one I am going to label in the left margin, as always, what class everything is from. Funda is my abbreviation for fundamentals. There's a lot of things that are in fundamentals, all the way from just word problems and understanding what they're saying with different types of word problems, all the way to converting between decimals and fractions, order of operations. There's all kinds of stuff in there. This is from fundamentals. It would be considered just a regular kind of word problem. You may also consider this percent apps. There's a lot of these that you'll notice that I'll label 2 classes or 3 classes. And what I usually mean by that is, depending how you think about the content, you may think of that as something that would require both classes to finalize your answer, or you might consider it to be one or the other. Because of the 3/4 here, which a lot of you probably turned that into a decimal, then it becomes kind of a percent applications, applying a decimal to a scenario. But it was also discovered as part of just the regular word problem section of fundamentals. So you have 2 people, and I strongly recommend anytime that you've got 2 people or 2 items, or 5 items is more common in this particular instance, write them each down. If you have a total that's different from those, you can write that down. Always kind of make yourself a little scratch paper list that helps you to ensure that you have all the info sort of set right next to itself in a nice organized list, where you're not trying to look up and down between your computer screen and your scratch paper and you've got this big mess going on. I would always start one of these by writing total is 15, and then whatever info you have. So at this time, what we know about Lori, she's going to pay 3/4. You might automatically say, okay, that's 0.75, or you might do that later. Either way, you know that if Lori's paying 3/4, and these are the only two people that are there, then you know that that means Jamie is 1/4 because that's what would make up a total of 1. We're assuming there is one bill. It is split amongst these two people. So if we know that one of them is 3/4, then we know that the other one is 1/4. And again, you may automatically say that's going to equate to 0.25, or you may worry about that later. It is easier to deal with these here than it is as fractions for most of you. So I would definitely say most of you probably did or should come into this format before you actually make the final applications, because that will be easier as far as the math. What we're being asked about is, if Lori paid 3/4, then what did Jamie pay? So we don't really need to know what Lori paid. We really only need to know that the total was 15, and we need to know what the person who paid 0.25 or 1/4 paid. And that's the only thing that we really need. And you should find that that is $3.75. This next one is from the fraction class. You're either good at mixed numbers and all the mixing of the operations by now, or you're not. And if you're not, definitely you want to get there by the time you're testing. What I'm going to do with this is I'm going to tell you what my steps were and what numbers I used, and that's it. So I always start out writing them out so that I can see what's a mixed number, what's a whole number. 2 in this instance, the middle number would become 2/1 because we're dealing with fractions. We want everything to be a fraction. And then 1/7 looks like that. So I wrote these 3 out. Those should match what you had. Then I converted them out of mixed numbers. There's only one of them actually that was a mixed number, and that's that first one is going to become 7/4. You're not going to have to do anything to the other 2 while you're in that step. The next one after that, you are adding fractions, so you need a common denominator for all 3 of them. The way you're going to end up getting that is to multiply them together. 4 times 1 times 7. If you disregarded the 1, that's fine. The 1 is going to agree with absolutely anything that you do. So what you really end up doing is 4 times 7. You know for a fact that if you take 4 times 7, each one of these denominators will fit into that common denominator, and that's your goal. So your next step from there would be to put 3 fractions out there with the common denominator of 28. From there, you have to determine how you got to each of the 28s and then apply that exact same method to the top number. So to get from a 4 to a 28, I would have multiplied by 7. If I multiply the top number also by 7, that would put me with 49 on the top of the first one. So 7/4 is now 49/28. With 1, obviously, we had to multiply 1 28 different times to get it to become a 28. So we're going to do that with the 2, and that's going to be 56. And then we had to multiply the 7 4 times. So if we multiply the 1 4 times, that is a 4. These were my final numbers that added up into what will later be the answer. The 3 top numbers add up to 109. Of course, the bottom number is still 28. And then you would convert into a mixed number by setting up a division problem that looks like this. Initially, I used my calculator to find out that 28 will fit into 109 3 whole times. I took 3 times 28 to find out what the difference is. When I subtracted that, I got 25. This is your top number. This is your bottom number. And this is your whole number. So when you put those together, you will get choice B, which is 3 and 25/28. If you have any trouble with that, that's from fractions and mixed number operations. You want to get better at whatever part of that is not working. So if common denominators where you fell off, or getting your top numbers once you've chosen that, that's right at the beginning of that class. If your problem was in getting this original conversion from a mixed number, that's the second half of that class. 3 is a combination of fundamentals and algebra. In fundamentals, we discuss averages and how those work, but you had to be more creative with this one because you don't know what one of the numbers is. The way that this problem sets up, I take all the numbers that I do know and I start to add them together, and I show that visually so that I can see that happen, because you know that you're ultimately averaging. The problem with this versus a normal average is normally we add them all up, we divide by the quantity of numbers, and there's our answer. In this case, the problem with that is we don't know what one of the numbers is. So no matter how we were to do the add and then divide, we would not get the right thing out of doing that. So the way that we fix that is we actually show X. So the last number that gets added on there is an unknown number. The number that we do know is what we want the average to be. So if you take all the scores we've already done on the test, you add the one that we're not sure about yet, and then you count those up. That's a total of 6. So you're doing all the things you would do normally to get an average, except you have to show them stacked out in their steps because of the fact that there's an X there. The other thing that we know is that whatever this is has to come out at or above 85 if we were to get the kind of score that we want. So if the average of the 5 existing tests and the one that's upcoming needs to be 85, that's what this looks like. You are more than welcome to pause and get a little bit slowed down with changing your thought process if you need to change the way that you did this. From here, it's just really algebra. So the first thing that I did was simplify what it looks like by a lot. So all of these 5 numbers, you can go ahead and add them together so that that's just one number instead of having all these different things. Obviously, you can't add the X into that. You've got to leave the X out of that. And so what I did was found out 416 is the total when you add up the existing scores. That's going to stay with the plus X. Nothing changes about plus X. And that's going to stay over a number quantity of 6. From here, this goes back to the basics that I teach in the first part of algebra about what you do when you have a complex situation like this, where this 6 is in the way of what we would normally do next. All you're going to do is multiply that 6 off. It's the same thing you would do if you had something like 1/4 X equals 10. The first thing you do is you multiply by 4 because that takes that completely out of there. And then you multiply by 4 over here. And in that case, you would have been done with your problem. 1x is 40. So that comes from basically the first page of the algebra packet. There's also a section of the algebra class about complex situations that literally look exactly like this. That might also be helpful if you're still struggling here. Most of you probably get this. I'm hoping that you get this part. What you were having trouble with is how do you initially put it together? How would you have gotten here in the first place? And that's combining fundamentals with algebra, which is what makes this advanced. If we multiply 416 plus X over 6 by 6, we get rid of both 6's there. So now I just have 416 plus X equals, don't forget that always what you do to one side of an algebraic equation has to then be done to the other side. And what you will get when you do that is 510 over here. So 85 times 6 is 510. Now you just need to do one more step to solve for X, which is just subtracting so that X is by itself. And what you will find is that you need a 94 at minimum. The fact that we used an equal sign over here says that we solved for the lowest possible test score that would allow us to do what we're trying to do. The answer choices are expressed with inequalities. So the way that that would work is you would have to get greater than or equal to 94. It can be 94. We set equal to the absolute minimum. So if you got a 94, your average in class would in fact be an 85. So it can be 94, which makes this underline right here crucial. And then it needs to be greater. So you would not want a sign that's facing with the open part to the 94, because that would say that you could do less than 94 instead of saying it has to be 94 or it has to be greater. So the greater number is over here because the greater number is where the mouth opens. Number 4 references number 3 again. This is also from fundamentals. Now they want a median. With a median, you have to put everything in order or it doesn't work. So you're going to take all of the scores that you've already been dealing with, and you're going to take this 95 that's now being put in as the 6th score. You're going to put those all together. I switched from commas to plus signs. I don't know why I did that. So you're just listing them in order from least to greatest. What that allows us to do is to say, as we move toward the middle, we can see what the median value is, which is the very middle actual number. We have 2 of them. And anytime that you're doing a median and it has 2 different numbers that are considered to technically be in the center, you add them together, you divide by 2, and that will tell you the true median, which is perfectly between 83 and 90. In this case, that is 86.5. We see that answer exactly under number 4. So even just looking at the first page, the first 2 questions on the first page would be considered an easy or medium at the very most category of question. So those 2 are very normal. Both 3 and 4 are overly challenging for problems in that category. It's very rare, although possible, that you have to do this X thing with an average. They can absolutely say, what would you have to score in order to get X amount in the total class? They can absolutely ask that. They are more likely to just ask you to average existing values. So this one stretches your thought process into the worst case scenario, considering how you would figure out an average, considering what the parameters of an average are. It's not to say you wouldn't get that question, but I really do doubt that you would get both of these back to back. Median is certainly something you can get asked, and you certainly could wind up having 2 medians where you have to average them. But again, that's the hardest possible scenario for a median question. So to have the hardest possible mean question immediately followed by the hardest possible median question, that's a little too hard. I'm going to do these giant circles around the actual number for cases where I'm saying that that problem is amongst the hardest possible. So that way, when you go back and try to scale your score a little bit, you have circled which ones are a little more extreme than the test so that you can consider them a little bit differently. Number 5 is a percent apps, essentially word problem. There is a little bit of regular word problem also involved with it. Essentially, they're asking you to make a comparison, and it's going to be key that you're organized on this type of question. There's lots of these that look just like this. There's lots of them in all of my mocks. There's lots of them on the test. It's not difficult at all, but it's a little annoying, and there's a lot of different pieces that you could miss, bringing something from your computer screen down to your scratch paper, or something that you could miss, you know, with a number that you accidentally don't account for, or you account for it in one place and not the other. So the key to something like this is organization. This is not an overly difficult question. I'm not going to circle it as a difficult question. If you write out Saturday and Sunday, you'll have a much easier time. The difference, remember, is that on Sunday, there is no sale, and Saturday there is. So on the side that you're doing Saturday, and I'm not going to talk through all this, I'm just going to show you the work so that you can pause if you want to see what it is. I would take my $9.90, I would put it on sale. It's 15% off, which means you can either multiply the 15% off and subtract, or you can just use 0.85, which is the reciprocal of that. So if I multiply by 0.85, I find out that the actual sale price on Saturday is $841.50. I then have to calculate what the tax amount is, and it turns out to be $46.28. So I add those 2 numbers together, and I find out that if I go and I buy this on Saturday, it's going to cost me $887.78. On Sunday, all I would have to do is take the $9.90, again, normal price for it, multiply that with the tax, and that's basically it. That's basically the last thing that I would have to do. And so what I'll find out is that the tax is $54.45. And so when I add these together, My total is 10, 44, 45. And in order to find out what the difference is, because what they want to know is how much more will you pay if you go on Sunday? How much more will you pay if you miss the sale? Let me get my charger real quick just in case it dies faster than it should. Okay, so you take the 10, 44, 45, the 8, 87, 78, and what that tells you is that the difference between the two corresponds to choice D, which is 156.67. Number 6 is a very simple ratios question. I'm not going to do any of the work there because this will get long if I keep doing this. It will come out to D. The two reasons it comes out to that is you have to change something from the original set of numbers to the set that you use. So you have to add a student of particular gender to the class. And then you have to swap the order because the order that they were in was girls to boys. And then later when they go to actually ask the question, they swap that and they make it boys to girls. So that is it for that one. And make sure that you reduce. So you had a number you had to add, you had to switch the way that the ratio was ordered, and you had to reduce the final answer. Number 7 is a fairly, I'm going to write ratios here. When I write ratios, I mean ratio and proportions, which some of the content for that class just says ratios. Some of it just says proportions. I'm not very good at file naming, and you may have noticed that at some point. It's all part of one class called ratios and proportions. That said, I don't have a lot of room with the way that I write on these mock tests in the videos, but I strongly encourage you to do more than what you're seeing me do here. So instead of just writing ratios on both of these, number 6 and number 7 are two very, very different levels of difficulty. Number 7 would be considered more of an actual proportion. Number 6 is setting up a ratio. Because you've done your classes, you should know what that difference is and be able to be a lot more specific with yourself. That will do nothing but help you if you can actually name them more specifically. So like if I went back to number 5, I could be more specific and say the majority of this problem involves scenario 3 in percent applications rather than just saying, oh, it's percent apps. So as you go back to find out what did I do really well on, what did I do really poorly, the more specific you can be over here. You have a lot more room if you're dealing with a pencil than dealing with a marker like I'm doing. You can be a lot more specific. You can say this is setting up and the order is weird or the reduction is weird, whatever you found to be challenging. This one is more like an actual proportion. Again, I'm not going to give a lot of info on 7. Most of you did fine. The hard part about 7 is they say the gas mileage is 10 miles per gallon. Some of you still, as you come out of classes, you still struggle to build this out. And I'm going to make a note. You've got to build that out. The word per is already in miles per gallon, and the per represents the line in a ratio. So 10 miles per gallon is the same thing as saying 10 miles to 1 gallon. So when they give a gas mileage or a speed, so like 25 miles per hour is the same way. They've already got the per in there. 25 miles to 1 hour. If you struggled with number 7, that's where you struggled, is you didn't stack this out and make it 10 to 1. This is the ratio they're giving you. When we do a proportion problem, they have to give you half of the problem. So there's 4 parts to the problem, right? They have to give you 2 of them that go together, and then they have to give you 1 from the other side. So there's 4 pieces. They have to give you 3. They have to give you 1 entire side, or you can't solve for the other side. And then they have to give you a partial side. If that doesn't all sound really like duh, obviously, you might want to go back and review proportions, because that's an important thing to be observant of as you're starting a problem like this. So we know that we have 100 miles and we have a tank of gas. And we recognize that tank is not the same thing as gallon. And we notice that gallon is actually what they ended up giving us. They didn't give us any info about tanks. Kind of turns out to be a trick question because the actual question ends up being in gallons anyway. So what they want to know is if you can go 100 miles on this tank, then you can go 100 miles on how many gallons. We figure that out by knowing that 10 miles would consume 1 gallon. If 10 miles consumes 1 gallon and we do our cross multiplication and divide, we would find that a tank allowing you to go 100 miles with this gas mileage is holding 10 gallons of gas. Number 8 is a ratio proportion, or you might argue that it's a fractions question. This is one of the ones I get asked about a lot. I've included it in the latest versions of the mocks just to give you a chance to go through this. These are not the real numbers. This is not the real problem. It's very close, and it's the same in terms of operations. So again, organization is key. I'm going to emphasize that a lot in the ones I go through. You have to have this organized or it gets confusing. You can get the right answer and wind up answering wrong because you have a big mess in front of you on your paper. So we need a category for scented and we need one for unscented. Then we need to make sure we're being really careful to put the right info in the right place. So a scented candle is 1/3 inch per hour. I would go ahead and change that to saying 1 hour. Anytime you see the word per and it doesn't give you a number to go with it, it's 1. So whether that be per gallon, miles per hour, or whether that be it burns 1/3 inch per hour, we're talking about just 1 hour there. Then the unscented candle is given to you as 1/5 inch. So inches matches here. We don't have 2 different units, which is one of the many tricks that they could do. However, this is 30 minutes. Anytime they give you something like this, it's going to be really obvious when you try to picture how the two relate to each other. So they give you 30 minutes. If there is one thing that you have got to be good at without ever having any math background, just by living your life, you know for a fact that 30 minutes is half an hour. So they're always going to give you something that's very manageable in that sense. What you have to figure out is in order to make the comparison they're asking you to make between these two, you need both of them to be in the same amount of time. It's hard to compare 2 different periods of time. The easiest way, in my opinion, to do that is to change from half an hour up to an hour, because then both would be in hours. Then you can see them side by side. How do I do that? I take the 1/5 inch and I multiply it by 2. It doesn't actually look like that when I do it, but mathematically you want to be in that logical place first. Well, if it burns 1/5 of an inch in 30 minutes, I need to know what twice that amount is, because twice times 30 minutes would put me at an hour. The way that actually is going to look, and the reason I say this might come from fractions class, is you're going to have to make 2/1 into a fraction, because that's the only way to multiply. 1 times 2 is 2. 5 times 1 is 5. So if it's 1/5 of an inch in 30 minutes, then it's 2/5 of an inch. And again, the math works out very easy. It's not really tough math in 1 hour. Now I have the same time standard applied to both of them, so I can much more easily tell which one is faster or slower. A lot of you probably decided to change these into a decimal format, and if you did, 1/3 is 0.333 repeating, and 2/5 is 0.40. If we're talking about how much gets burned in an hour, burning 40% in an hour versus 33 would be the one that's faster. Always go back to check what your question asked. I wouldn't remember off the top of my head whether they wanted to know faster or slower, because obviously that drastically changes your answer choice. In this case, they want to know which burns faster, what is the percentage burned in 1 hour. So the one that's faster is unscented, and I know that because I stayed very organized here, and it's going to be 0.40, which is equivalent to 40%, and that is choice B. The candles question is most definitely on the test. I get asked about it a lot. Those are not the actual numbers, nor is it the actual answer choice format, but it is the thought process. You would probably find the actual questions about that on the test to be a little bit easier than what we just did. 9 and 10 are part of a very advanced segment of ratios and proportions. Again, these are proportions, not ratios. It's just easier for me to write ratios so that you know what class it's from. These are, without a doubt, the hardest as far as proportion problems. I don't cover these in every level of class. I cover them in the advanced classes and the intense classes because they are, for most people, a little harder than what is necessary. If you are retesting, so if the reason that you're seeing Mach 5 and 6 is because you're retesting and you're trying to get much higher or even a little bit higher than you already got, these are the kinds of problems you can now add to your repertoire to be able to get extra points that you didn't get before. So most likely the last time that you saw these questions, you didn't necessarily know how to answer them, or you didn't confidently know how to answer them. That would be something to improve this time. So I put 2 of them back to back. I also put them in Mach 6. So if you're ready to have exposure to one more level that's even harder than what you've already seen, this is where you'll see that. So I will do a full explanation for 9 and 10. With these problems, you need to get a little bit of a picture going in your mind of what links to what links to what. That's the key to this whole thing. The whole premise behind problems like 9 and 10 is you can make one comparison to another, and then you've got to make another comparison that's to a whole different thing that doesn't relate back to the first thing, and you end up with a chain of proportions. And if you wanted to name these 2 question types, you could call them chain proportions or multi-part proportions. So there's 2 apple trees to every 3 peach trees. So if I have 2 apple trees, I know for sure that I have 3 peach trees, which means if I'm given a quantity of one of those 2, I can get the other. And then separately, if there are 4 peach trees, so this one picks up where this one leaves off, then there are 5 pear trees. What's hard about this is usually it's like they're going to give you a quantity of pear trees and ask you for apple, or vice versa. They're going to give you a quantity of apple and ask you for pear. You cannot go directly from apple to pear. We have no idea what the correspondence is between those. There's also no shortcut to that. Some of you were probably tempted to do something like 2/3 to 4/5 to try to get them linked up. And what you notice is there's no variable missing because these are 2 entirely separate proportions. You can't combine them. You can't, from where we're sitting now, from the info that we have right now, there's nothing you can do to get closer to finding out how apples relate to pears. There's no easy way to do this. The only way you can do it is start where you have additional information and then do proportions until you get to the unit that you want to be in. So what did they actually give us? They actually gave us apple. So I can't do anything with this over here because I only have apple. I only have knowledge of apple. That actually does something very important for me, though, because if you think about this first proportion that they gave us, we can compare apples to peaches. What this actually does is it gives us our whole first fraction. 2 apples is to 3 peaches. So this becomes that first known part of the proportion. And what this does is it gives me a 3rd unit. So this is apples, this is peaches. Now I have another quantity to put here with the apples so that I can find out the number of peaches. So when they gave me this number 8 apple trees, I can only use that 8 apple trees for one thing. There's only one thing that number can do for me, and that is to tell me how many peach trees would exist in that scenario. So if there's 2 apple trees, there's 3 peach trees. That means that if there's 8 apple trees and they're telling me that there are, then there's how many peach trees? And the number that I got for that is 12. So in this first proportion, what we found out is that X equals 12 peach trees. If there are 8 apple trees, there are 12 peach trees. Now we have a quantity of peach that matches up with the given info from the problem. Now we can actually bridge over to this other side and get over to pears. And we do it in the exact same manner. We start over again. We bring this number in. So first we started over with this number and we brought that in. Now we've got a number that matches up with peaches. We're going to bring that over. And again, we're just going to start back at the beginning. So this proportion on the right-hand side of my little line that I made is peach is to pear as peach is to pear. 4 peach trees to every 5 pear trees is my first given fraction. So 4 relates to 5, 4 peach trees to 5 pear trees, in the same way that 12 peach trees relates to X. If you find this even a tiny bit confusing with the names, spell them out. Maybe not even use letters, but actually spell them out. If this is confusing to you over here, because 2 different kinds of trees start with the letter P, write them out. 2 apple, 3 pear, peach. See, that's why it's confusing. And then when you get your 12 peaches, you might go back here and say 4 peach to 5 pear, and you might write it all out. Do that if you think you're going to get confused sometime during your problem as to whether you're dealing with peaches or pears. If that's going to be confusing, that can either be solved with this line. To me, this line being here solves that for me, because when I'm on the left side, I'm thinking peach, and when I'm on the right side, I'm thinking pear. If that doesn't work for you, I strongly endorse the idea of writing out the proportions to make sure you have the numbers in the right spots. So what do I end up finding out? I end up finding out after solving this proportion that would correspond to 15 pear trees. And what I just did is I took the fact that there's 8 apple trees, and I used that combined with this given info here to find out how many peach trees that is. Peach is a magical term that then allows me to access a new proportion that I was not able to access when they told me 8 apples. So once you use the apple to peach relationship, then you get over here to the second given. You use your peach trees that were from here to find out how many pear trees that is. And because of the 2 separate comparisons that we have, we can use 2 separate calculations and find out that 8 apple trees corresponds to a certain number of peach trees, which then corresponds to 15 pear trees. Definitely listen to that again. If you want to, definitely try it that way. If you didn't do it that way or you had trouble, try, getting out a new piece of paper and trying the chain by yourself, then replaying the explanation. Again, the next problem, number 10, is the same way, and mock 6 will have another couple of those as well. There's also one more really challenging ratio type that is still coming up within this test. So after I do number 10, I'll skip through as many of these as I can to get us advanced further into the test so it doesn't take too much time. Number 10 is a more, I guess you could say, a little bit more complicated version of what we just did, only in the sense that there's like an extra pair of things. So when I wrote all my pieces out here, and definitely try this one on your own if you feel good about number 9 now, and you didn't feel good about number 10, go ahead and pause and try it without me even having explained it. If you want to see this one explained and then retry it, you absolutely can. Or you can watch the explanations here and plan on being ready for these when you get to 6. This was the way I wrote these out. I always try to write out everything so I can see all the different relationships stacking up. So the first piece of info they give us is red related to blue. So if there are 4 red then there are 7 blue. And then if there are 7 blue, there are 8 green. This 7 and this 7 are a coincidence. I did that on purpose because that is also an extra source of confusion. They have to tell you each one of these specifically. They have to specifically give you each and every one of those comparisons. They just so happened to use the number 7 for blue in that instance and in the following instance. And then they said there's 7 blue to 8 green, so 7 blue equals 8 green. Then they said there's 1 green to 2 yellow. And then they gave us a number that we can then chase back through all the different proportions. Same exact thing we did above, except there's an extra set of them. And we always have to start where we have information. So what information we have is that there's 80 yellow. If you look at your list of sets of proportions, only one of them has anything to do with yellow, and that's this one here. So the first number you're going to be able to get is the number of green marbles. You can't go from yellow to anything else. You have to go to green from yellow. So if I have 1 green to every 2 yellow, that is my given side of my proportion. I can then set that equal. 80 is the one that's on the bottom in my proportion, so I need to make sure yellow stays down on the bottom. So in this particular case, what I don't know is how many green, and that happens to be the top number. Doesn't actually matter as long as you have both greens in one place and both yellows in one place. So then when I go to solve this, let me look up what my numbers turn out to be. I end up with 40 green. So if the relationship between green and yellow is 1 to 2, then if I had 80 yellow, I would have 40 green. I can then take that and I can go into the proportion that has blue and green, and I can say 7 blue is to 8 green, as an unknown number of blue is to our newly found 40 green. How do we know that we should put 40 green into this proportion with green and blue? Because we got that from having the number of yellow, and we just keep walking backwards through the different proportions. You will find out that there are 35 blue. And then you have one more proportion that you can plug those into, because now we have blue. That puts us in the final proportion, which also happens to answer the actual question, which you always want to pay very careful attention to. How many red is the question? Always know that going in, because it's possible you don't actually have to use all the info. They could have given you a number of yellow and just asked you for green, and half that crap would have been irrelevant. So always make sure you know what the question is. In this case, they did make us walk through every one of them. So now I'm going to go 35 blue, and I'm going to go into my final proportion, which starts with 4 red relates to 7 blue, in the way that 35 blue, which goes down on the bottom with my other blue, relates to an unknown number of red. And what I get there is 20 red marbles. Again, you can watch those explanations a couple of times. Even as much as I'm slowing down to explain those, it's still a very fast explanation because there are so many pieces. It could literally take us 20 minutes to just do one of these. So go back, try it. You definitely work through these very slowly when you're getting the hang of how to go from one ratio to another, to another, to another. That is a slow thought process until you master it. Once you master it, you almost go out of body, and your eyes start naturally matching words together so that you know where to go when you get new info. Again, these will be reiterated on Mock 6. Definitely, if you weren't going to do Mock 6 and you want to see more of that type of thing in other worst case scenarios, that's a great place to see it, because 5, 6, and eventually 7 will be focused on these really hard ones. 11 is a ratio and proportion as well. This one might be tricky to some of you, but not to others. So what I'll do is I'll just show you sort of what my work was in the interest of moving on. So 7 minutes is the pace for 1 mile in the first runner. So if 7 minutes is 1 mile and they finish the race in 14 minutes. So what we didn't know, 2 runners are competing in a race. One averages a pace of 7 minutes per mile. What we don't have yet is how many miles are actually in the race. What we do know is 7 minutes is 1 mile. Now we've got another quantity of minutes that we can use. They gave us the total number of minutes. So they gave us the minutes that were involved in pace and then the minutes involved in total, all for just the first runner. We're not worried about the second runner at all yet. Knowing that it's 14 minutes allows us to see that with this perfectly even 7 minute per mile pace, this must be 2 miles. If you can run exactly 7 minutes per mile and it takes you 14 minutes, it's exactly 2 miles. We can then use the 2 miles to find out if somebody finishes the whole thing, which is 2 miles, in 28 minutes. What was their pace? Their pace would be a perfect 14 minutes per mile. That is not pretty the way that I just set that up. I actually did that in proportion, but that one was only challenging if it was challenging from the perspective of finding the pieces of info. The proportions was not the challenging part on that one. Again, if you have specific trouble with one of these, try it again, watch my explanation again. You can always write down the timestamp on the video when I reach a question that's important to you. I do not know what the timestamp is right now. I'm being completely random and guessing. Let's say it's 11 minutes and 25 seconds into the video when I start working on number 11. I know we're a lot further behind than that. That would be something you could write down so that you can focus on the walkthrough for now, go back, try 11 again, knowing what the answer is, see if you worked out where you were having trouble finding something, watch the explanation again, whether or not you figure it out, and so on. If all of that you're still confused, then you would send that to me. 12 is also a really hard instance of ratios and proportions. And again, this is one of the ones I get asked about all the time. This is a combination, actually, of algebra, and ratio, and proportions. And again, a lot of it has to do with organization. So you have a trip that's from city A to city B, and that takes 5 hours at an unknown speed. And you kind of have to read this particular problem a few times to figure out whether you were given certain info or not, because it's very unclear the way that they say everything. Then you went from city B to city A, which hopefully you noticed that was the opposite. And that took only 4 hours. Again, unknown speed. They did not tell you the speed you were traveling in either instance. That's what makes this much harder than your typical proportion. But they did say that when it took 4 hours, you were going 15 miles per hour faster. So now what we want to think about is how could we make that relatable? There's 2 ways to make a proportion work. There's 2 ways to build a proportion. One is the usual way, which is that you are given 3 out of 4 pieces of info. What you'll find here is you were not given 3 out of 4. You were given essentially 2, if you want to be really nice, 2.5 of the 3 pieces of info. So what I mean is you could put in here, you could start to build a proportion, 5 hours. You could say you're going to put the hours on top in both. So you'd have 5 hours and 4 hours. And if you're doing speed, right, you would get kind of stuck here because you don't have a speed to put into either of them. What we have instead is the other possible way that they give you a proportion, which is always going to be considered extremely advanced. Very, very difficult if it's in this format. is a relationship. So we can either make it where only one thing is missing, or in this case, we can make two things be missing if we relate them to each other. So that's what they did here. Instead of saying it took 5 hours and you were going this fast, and then it took 4 hours, so how fast were you going? That would be very simple. You would already be solved and out of here. Instead, they gave you 5 hours and 4 hours, and all they told you is that the shorter trip, you were traveling X amount faster. So if I'm thinking about speed as the bottom part of the proportion, what do I always do when something is unknown? I always put X, right? You always have an X in your proportion. We have no idea what speed this person was traveling when it took them 5 hours. So just like in any proportion instance, that's X. That's an unknown number. So we're going to say that this, instead of a question mark for speed, we're going to name it X, just like we always do. What that leaves you with is what do you put here, because we still have missing info. If we know that you were going at the speed of X when it took you 5 hours, then we know that you were going X plus 15 on the second trip. So when it took 5 hours, you were going at a completely unknown speed. When it took 4 hours, you were going at an almost completely unknown speed, but you happen to know a little bit more about this than you knew about that. So we can end up with X in our proportion twice because it's X in both instances. What I mean by that, you could not have X in one spot and Y in another. You would never solve that. It would just turn into a bigger and bigger and bigger mess. If you're only given 2 pieces or 2.5 pieces of the proportion, the only way you can actually solve that is if you can relate the missing halves to each other. If you can get X in there twice with a relevant placement of X, you can't just put X in both spots because that wouldn't be accurate, then you can actually go ahead and solve this. This is where it really borders on being algebraic as opposed to just a ratio, but that's what you're looking for. So be prepared. And again, you've probably not seen a problem of this structure or quite this hard unless you've seen it on your test, because I usually avoid ones that are of this high of a difficulty level. But if you are trying to get that 1 more point, those 2 more points, this is how you do it. You learn how to compare the apple to the peach to the pear, the red marble to the yellow to the green, and this. This would be considered an algebraic proportion. So if you are sitting here thinking, yep, I'm going to get good at these other newer types of proportions that are harder than what I did before, I'm ready for that, let's do it, let's get those points, you would consider number 9 and 10 to have been chain proportions, where you have to use multiple proportions and you have to go in a certain order. And then you would consider this to be algebraic, where you have to identify an X and then something else that can be related back to that X. If you're confused on the setup here, it might be a good plan to pause, go back to the actual word problem because you can't really read it when I'm talking, and see why I'm saying what I'm saying here. And again, if you're somewhat following, want to keep getting directions, come back to this later, write the timestamp down, try it again on your own. There is going to be something weird in how this solves out because this is such a difficult problem, but you're going to now be prepared to do what you always do, which is cross multiply and not exactly divide in the traditional sense, but let's look at what happens when we cross multiply. So the first thing we would multiply is 5 times X plus 15. Now, when you say that out loud to yourself, your algebra skills should kick in. When you say 5 times X plus 15, that looks like this. That looks like distribution. The 5 ends up getting multiplied by the X and the 15 separately because there's a plus sign between them. So that would be my first side. and then equals. There's always an equals and a proportion. The other side, you have 4 times x, which is just simply 4x. You may feel like you haven't gotten anywhere here, but you totally have, because everything is either numerical or it's in x. You know how to do algebra. So if everything is in the format of an x, you know how to deal with that. If everything is numerical, you're already done and out of here. So I'm going to distribute this 5x plus, and 5 times 15 is 75 equals 4x. At this point, you'll notice that your problem ends up with a negative in it. You can completely ignore that because there are not negatives when it comes to speed. So I'm going to take my x's. This is just like a multi-step equation in algebra. I'm going to take my x's and I'm going to put them together in the same place. What that's going to leave me with is a 75 still on the left side of the equal and a negative x on the right side of the equal, because we had 4x and then we subtracted 5x. Ignore the negative. Don't even worry about the negative. There's no such thing as a negative speed. It pans out that way because of the way that they gave the algebra. It shouldn't be that way. That's not proper and correct, but that is how they write it, and this is how you solve it. So essentially, you just have to adapt to that slight weirdness. So x equals 75 may or may not be our answer. So you want to go back to where you were before, and you want to fill in your newly found information. So we no longer have an x, right? We have 75 miles per hour. That's also going to go here. So in the trip that took 5 hours, which you might recall was the trip from A to B, we were going 75 miles per hour because that's what x solved out with. And if you remember your proportion, x is what we had here. Then, if you want to know what the 4-hour speed was, you have to go back to what you knew before, but you have to add in the speed that's now known. So we were going 75 on the 5-hour trip, and we know that we go 15 miles per hour faster on the trip back. So that would end up being 90 miles per hour. We solved for x. That's all you can do, is bring it down to a variable like x. Then you have to adapt the rest of the problem logically. If x turned out to be 75, then it took 5 hours going 75 miles per hour. It took 4 hours when you upped that by the appropriate figure and went 90. Now you need to check very, very carefully, what was their question? What did they actually want? Because as you see, 75 is there and so is 90. And they're both correct answers, but they both answer a different question. They said, which of the following is the average speed from city B to city A? Which is this one, which is the shorter time, which is the faster of the two speeds. So we are going to answer this with D. They're asking us how long it took on the 4-hour, or what speed, I'm sorry, the 4-hour trip was. That's the faster speed because it's the shorter time. This could very easily have been answered 75. The only difference would be that they said, what is the average speed from A to B? And you have to be very careful of that because you've been lost in math and algebra and all these frustrating things for a while by this point, and you have to go back and make sure you're answering the correct question. So try that again. Try it a couple more times. Find my logic in that. It is very abstract. I don't expect that it just makes sense like the snap of a finger, but you do now have the tools to see the comparison that I am making, and you can now see why my theories are mathematically valid to make that work. But you want to get familiar enough with that you are ready to set up a proportion that involves a double instance of algebra. Again, I believe that question also is on Mock 6. Mock 6 is being finalized like later today, and you'll have all of those hard instances again. I'm going to see how much of this I can kind of fly through now. 15 is from fundamentals, or 13, I'm sorry, is from fundamentals. 13 wants to know 0.5% as a decimal. Make sure that you write the percent and then you do the steps that take you from a percent to a decimal so that you make sure that you get the right zeros in the right places. That should turn out to be C. 123% as a fraction, again, from fundamentals. And again, you need to take your 123%, follow the appropriate steps to turn that to a decimal. The decimal of 123% is 1.23. Now we're ready to put it in a fraction, and the way we do that is we find our decimal, count tenths, hundredths, and whenever we stop, that's our bottom number. So we're going to have 123 over 100. The decimal part of the number is the only thing that qualifies for that. And if you're not careful going from percent to decimal, you may be playing from a wrong place to begin with there. How many centimeters are there in 800 kilometers is number 15. That is metric to metric. This is a two-step, and I know that because everything given in my problem has a prefix. I don't see meters by itself anywhere. So my first step is to go from kilometer to meter. My second step will be to take that figure that I get for meters and go to centimeters. Both of them have the same logic. You should have done them absolutely separate. When you do a two-step metric to metric, you should ignore the fact that there's another step and do the math totally separate. That said, you will find from a writing standpoint, you're going to write the exact same things down under each of them. What you're going to write is we're going into a smaller unit, which means we need more of them. So we're going to multiply, and we're going to multiply by the number that currently exists in the problem and the prefix number. And then you'll notice that when you go over here, you get the exact same components. That's just a coincidence. One thing I am going to note is after you do all of your multiplications, you do this, the number that you get for meters so that you can check your progress on this problem was 800,000. So the result of the first half of the problem and the starting component for the second half is 800,000. You then end up multiplying that by 100. Count the zeros on your calculator. Anytime you're in millions, even 100,000s, count the zeros on your calculator. It will save you from ending up with an extra or a missing zero. In this case, I counted 7 zeros. So I had 8 and then I had 7 zeros. 1, 2, 3, 4, 5, 6, 7. Then you go from the right because you know that millions and billions and trillions and all those ridiculous numbers are in chunks of 3, right? So you've got your last 3 there. You got your next 3 there. That will leave you with a certain quantity of zeros or with no zeros left there. The answer to this is 80 million. If it had had 6 zeros, it would have been 8 million. And you would have done the same thing. You would have counted the zeros, written them out, gone in chunks of 3. And when you put your last comma in place, all that's left to the left of that is an 8 as opposed to an 8 and a 0. The way you get from your calculator to your scratch paper and you verify that you're picking the correct massive obnoxious number, because there might be multiple of them, is you count the zeros and you go from the right in quantities of 3 until you run out of those. 16 and 17 are American to metric or metric to American. I consider them the same thing. The key to these is your flow chart. Both of these, the key is you have yards to feet to inches to centimeters. You're either going to start within the flow chart or you're going to start on the right-hand side of the flow chart prior to even having centimeters. In the case of number 16, we're starting at inches. So we can ignore yards and feet. 52 inches is how many centimeters? Always slow down and do the actual full, complete thought process. 52 inches. Inches are bigger than centimeters, which means we're going into a smaller sized unit. You need more of them. You're going to multiply. So you're going to take 52 times 100. I'm sorry, 52 times 2.5. We're still in inches to centimeters. Always have these numbers filled in. I'm always kind of lazy when I do my flow chart. There should be a 3 there, a 12 there, and a 2.5 there every time that you use this flow chart. So right here you have 2.5 centimeters to each inch, which means you're going to take 52 times 2.5 to get your quantity of centimeters. That's going to be 130. Then it asks for meters. So now we are done with the flow chart, but we're not done with the question. We need to go from centimeters to meters. If we have 130 centimeters, we're going into, always write this out, into a bigger sized unit. We need less of them. We have a bigger unit to use. We don't need as many. So we're going to divide, and we're going to divide by 100 in this instance. So that's going to come out to 1.3, which is the same thing as 1.30. On number 17, we actually start over here before we can even use the flow chart. We're in meters. To use the flow chart, we need to be in centimeters. So to go from meters to centimeters, you're going into a smaller sized unit. You need more. You multiply. So you're going to take the 120 that's part of the problem times the 100 that's what centimeters would always correspond to. And what you're going to find is that you have 12,000 centimeters. Now, as we go left on the flow chart, we are dividing at each step. We're getting into bigger and bigger and bigger and bigger units. The flow chart is great because if you're moving to the right, you're multiplying, and if you're moving to the left, you are dividing. So we're going to divide 1,200 by 2.5 to get the number of inches, which is 4,800. We're going to divide that by 12 to get the number of feet, which is 400. We're going to divide that by 3 to get the number of yards, which is 133 and 3 is repeating. That is C. If you answered D, you weren't paying attention to the rounding. That's another one of those things that kind of makes this harder than your test. They're not usually quite that aggressive with the rounding, but sometimes they are. You'll notice I did that a lot in this case where I put answers that are so ridiculously close together that you could overlook something very minor and wind up with that. So these answers are a little bit close. I have not been doing a good job of circling the questions that were hard. I'll go back and do that as we finish. Number 18 is from geometry. A triangle with these two side lengths has a hypotenuse of what? You are fair to assume it's a right triangle here because that's the only way that we can do the hypotenuse in the formula. And basically what you're going to do is put them all into a formula. When we take the two different side lengths and we square each of them, we multiply them times themselves. What we get is the hypotenuse at the time that it is squared. So 24 times itself is 576. 7 times itself is 49. And those add up to 625. That doesn't mean the hypotenuse is 625. That means that when you square root 625, you get the hypotenuse, and the square root of 625 is 25. What you do when they give you side lengths or ask, you know, they can give you in either order essentially, so they can say if a hypotenuse is this, what are the sides? Or if the sides are this, what is the hypotenuse? What they're asking you to do is plug everything into the a squared plus b squared equals c squared to find a factual statement. All of these numbers, if you squared them and you put them over here, you would find that you had an equal sign when two things were not equal in the first place. 19 is algebra. A lot of these algebra ones, I'm just going to kind of fly through and give you the answer. And if you have questions on them, go back, work them, let me know. 19, first you had to distribute here. Then you had to make sure that everybody was back into their original place after the distribution with the appropriate signs. You put all the X's on one side, you put all the numbers on the other side. And what I wound up with every time I solved this was 17 over 26. And that means that you ended up with 17 equals 26x, because that's what results in that. So when you combined all your x's together with the appropriate positives and negatives, you got 26 of them. When you combined all your numerical components together, you got 17 of them. Both of those numbers were positive. So they both wound up as a 17 over 26. Number 20 is asking if x represents 10, then what does this statement become? Which means you're going to put a 10 in everywhere that there is an x. They're quite literally telling you that x is now 10. We now know the value of it. So when we do all of that in this particular instance with the negatives accounted for, we're going to end up with negative 24 as the result of this entire thing. Watch your order of ops. Watch the tricks of order of ops. You're going to end up with all positive and negative, plus and minus. So you're going to go left to right after you do the multiplication. So first you've got to multiply that and that. Then you're going to go left to right, which means you're going to do plus, minus, something like that. And you're going to do all of that in your calculator so that it comes out with the order of ops. Number 21 is from fundamentals. There is a little bit of extra info in here. You just have to read the scenario and the story and the outcome and everything carefully to get that. And then you have to split up some different things, and there's a lot of moving pieces. This would be considered fundamentals. It's not considered a difficult problem, but it is considered to be what I would consider at least a major pain with all the different things. What I'm going to do is show you where I ended up as far as my equation that resulted in my final number. That will give you what you need to go back to if you don't come out right. You can see what I've got put together, why I've got it put together, and then you should be able to reconcile your difference. So what I had in solving this, I had to go through, I had to figure out what I needed to multiply by the 40-cent charge. Then I had to figure out what would be remaining after that to put over here. So I had to take the total number of miles, which was eventually given right there. I had to put that into the first 200, and then I had to figure out what would remain to be charged at the other rate. The 200 is an upfront fee. The 20 is another upfront fee that's for extra insurance. Nothing happened to the car, which makes the $50 deductible irrelevant. It does not end up in the final problem. Everything else does. The only thing that doesn't is the deductible if the car were damaged, but that doesn't give back the 20 bucks that she paid to have that insurance. So that still goes in there. So this is insurance. This is a fee. This is the mileage for the first 200. This is the mileage for anything in excess of 200. When you do your multiplications with these decimals here, and then you add it all together, her total cost would be C, which is $372. If you had any trouble with this, you'll probably find it right there in the way that the equation is written, or you'll find that you had a mathematical error probably that happened right after that. 22 is from algebra. Which of the following is written in this scenario? So you have to read it carefully. 2 times a number, hopefully by now you're like, yep, 2x plus 10 is less than or equal to 20. That's the part you have to be super careful with, is what does less than and greater than look like. The mouth opens to whatever is greater. In this case, they're saying whatever's over here, which is 20, that's what's greater, because this is supposed to be less. So you want the pointy part toward the 2x plus 10. And then they did say or equal to, that's what creates an underline or not. So that's going to end up being choice D. Which describes x in the solution to this equation. So this one, you're going to have solved this. You have all the necessary components to find out what the actual value of this equation is. It looks like this if you need to go back and look at it. That is your final answer, and that is x is greater than 2, which is B. That is also algebra. 24 is, again, lots of steps and complications, and it's a crazy problem of lots of distributing and combining and moving and solving and all of that. You should come out with D, which is 2/9. If you had trouble with that one, it is most likely some type of oversight somewhere in all of the operations. Try it again. You'll probably end up finding it was simply a mistake. If you truly don't understand how to get to 2/9, then that would be a different issue. But I rarely have people say they actually don't get those. I just usually hear there was a mistake in calculation. The longer and more cumbersome it gets, the more likely a mistake is. This is harder than 99% of the algebras on the test. If you can do one that complicated without making a simple mistake or oversight, you can do anything that they actually put on the test. 25 is a simple organization matter. It would be considered percent apps combined with a regular word problem. The key to this is to list out your quantities, your different things. These are both deodorant, so you might have done that as $2. That's fine. Here's all the things he bought. I add all of those up, and it's $11.90. When I go to get the tax on it, I take that $11.90 total and I multiply it by the appropriate percentage given for the tax, and I find out that there are 83 cents in tax. When I put $11.90 and 83 cents together, I find that the total expenditure is $12.73. That's not the question. The question is, how much change would he get if he gave the cashier a 20? So there's one more step, which is to take 20 minus 12.73, and you'll find out that the change back would be $7.27. If you missed that one, it was probably a matter of organization, forgetting a component of the shopping list, or an oversight of what the answer was supposed to be, which is the change back from a $20 bill. 26 is something, there's a couple of them coming up here that are new to the test, and they're actually old content from the TEAS 4 and the TEAS 5 eras that are coming back. So I'm going to show you how you would do 26. I encourage you to practice this with any set of perfectly square rooted numbers that you can come up with to get better at it. Again, it'll be reiterated in version 6. Best estimate for a square root. So this will end up in fundamentals class. Fundamentals class is being redone relatively soon. It's the end of January 2019. So if you're seeing this from like March 1st on, it probably was taught in the class and you have already seen this. So when you're doing an estimate for a square root, what you have to do is you have to come up with numbers that are perfect in square root that are around that. So when I take 12, and I'm going to put a box around it, you'll see why later. I want to think, what is the next nearest number less than and greater than 12 that have perfect square roots? What you'll always find is they're only one digit from one another in their square root. So all of your answers are super close together. They're all within the same parameter. You can tell what they did here because it's not like the answers are spread very far apart. What they did is they said the closest number beneath 12 that has a perfect square root is the number 9. And the number 9 square roots to 3, and that's how they're getting that 3. The closest to 12 on the other end that square roots perfectly is 16, and that would be 4. So the number that lands perfectly between 9 and 16 would be the 3.5 that's exactly in the middle of those two. That doesn't happen to be 12, and here's how we find out. How many numbers are there between 9 and 16? So there's 9, 10, 11, 12, 13, 14, 15, and then 16. I did that very unevenly. I apologize. So 10, 11, 12, 13, 14, 15, and 16. Ignoring 9 and 16, how many are there? There's 1 and 1, 2 and 2. Right between 12 and 13 is perfectly centered between 9 and 16. So we count the same way we count when we're trying to do a median, where you come here and you say 10 and 15 are the furthest out, 11 and 14 are the next. You can't cross off 12 and 13 because there has to be something perfectly between them. You can average those, or you might be able to tell by glancing. The value that lands perfectly between 9 and 16 is 12.5. So that 12.5 is perfectly between 9 and 16, which means that its square root, if you were to estimate it, would also be perfectly between 3 and 4. So this is the square root. So when you go to approximate a square root, you take the nearest values and make sure they are the nearest values that do have a perfect square root so that you can identify those there. You'll notice your answers are always within that range. Every single one of them is. The next step is to find the perfect center. The perfect center tells you where the 0.5 is supposed to be. So the perfect center is 12.5. 12.5 would correspond to 3.5 when you're going from numerical to square root. Where were we at is now the question. We wanted to know about 12. You leave your numbers all spaced out like this because it makes it very easy to tell what is going on, right? So you can see who's close to 9, who's close to 16, who's close to the center. Then you can determine the value I'm looking for. Where would that fall? 12 is very, very, very close to 12.5, but it's not 12.5. So when we go to look at our answers, we know it's not D, right? Because we know what would correspond to that exactly, and that would be 12.5. So it's not 3.5, but it's darn close to 3.5. So it's probably going to have to be the one that's 3.4. How do I know it's not the other two? 3.8 is halfway between this middle point and this point over here, which is around 14. 3.2 is halfway over here, which is around 10. If we were approximating 10, we'd answer somewhere around 3.2. If we were trying to approximate 14, we would do somewhere around 3.8. If we did 12.5, that would be perfectly 3.5. They will actually space your answers out just a little more than I did. I made it a little harder because I knew that we would identify the 3.5 and know that that's not the answer. Most likely your choices on this would be like 3, 3.2, 3.4, 3.9. And that would give you enough space to know that you're confident in what your estimate is. 27 is kind of a classic messy discount and tax rate and all that with percent apps. It all falls into scenario 3. You want to make a good list, discount everything, add it all up, take the tax rate, add that on, and so on. And what it wants is the total cost of the purchase after all the different items are put together. They're discounted appropriately to what they are, and the tax is added on. That's going to put us at B, which is 367. It's 361.57. 28 is from metric as well as general science 2 or science reasoning 2. Metric approximation. The only thing that is sitting here that could possibly be a pizza box would be 1/2 meter. 1/2 meter is about 1.5 feet, give or take. And you are expected by this point to be kind of able to move between the different units with some fluidity, being able to figure out sort of the differences between the two and how you can have a frame of reference for everything. When I see half a kilometer, that's like half a mile, right? So you've never ordered a pizza that big. It would not fit through your door. So you know it's not half a mile. 5 millimeters is about this big. I don't think you've actually ever ordered a pizza that small. And then 5 milliliters is liquid volume, and a pizza box is a length measurement. They're asking you the length or the width of a pizza box, not liquid volume. So if it's got an L in it, it absolutely could not be the answer. You can see these on the science or math test, the approximation ones. I've done my best to put all of them in front of you that you actually could see. Something that I have seen recirculate on the test just in the very last time I saw it, which was not a couple of weeks ago at the most. Roman numerals were always part of earlier editions of the test, and now they're kind of coming back. I truly think that these are pilot questions, which means they're unscored. I don't think they actually have scored Roman numeral questions. That said, if you are taking this class because you are trying to score nearly perfect, or you're trying to improve a lot in any possible way you can teach yourself Roman numerals very easily. Again, this will be added to the fundamentals curriculum shortly, just in case they decide to start scoring it. Since I have no way to prove what a scored question is versus an unscored, if you're trying to make every single point count, look up a chart for Roman numerals and just get to know there's essentially like 100, 1,000, 50, 10, 5, and 1. You already kind of know the 5 and the 1. That's the 5. So if you did 7, it looks like that. If you did 4, it looks like that. Those ones you're probably kind of used to. 10 has a letter that goes with it. 50 has a letter. 1,000 has a letter. 100 has a letter. The answer to this one, you'll notice there is not a 20. There's just a 10. 10 is X. So to make a 20, you have to have 2 X's together. And then to make a 7, you need a 5, 6, 7. So that's going to correspond to B. The problem with D is it has the letter C, which is 100. So this is 117 for D. So that's way too big. Anything with a C is going to be too big for a number like that. L represents 50. So again, that's too big. This would be 57. And then this one's very close, but it's 6 instead of 7. So this is 26, 27. So if you're trying to get every single point, go look up a good Roman numerals chart. Don't try to memorize all the numerals. It's obnoxious. Just know what the big letters are so that you can put them together yourself. 30x has a value of 15, y has a value of 11, so you're going to change x to 15, you're going to change y to 11. Don't forget the other plus 10. You're going to follow your order of operations, and you're going to wind up with 78 for that one. That is algebra. 31 is percent apps. They give you a total. Your total is 560. They give you 2 percentages, and then they ask you a percentage that corresponds to something else. You can do this one of 2 ways. You can either find the number that take French and the number that take Spanish and subtract them out of the total, or you can combine the percentages, figure out the percentage that are German, and then multiply that by the total. So you either dealt with the actual numbers or you dealt with the percents, and then you looped back to the other side, whichever side you weren't using. What you should have found is 252 students taking German. 32 is percent apps, specifically percent difference, which is one of the harder ones from the percent apps class. You're always going to take the difference, which is going to be obtained by subtracting your 2 numbers over the original, which is the original price in this case. So you're going to get your difference by subtracting 39 minus 22. And then you're going to get that into a percentage by dividing by the original price of 39. So you're going to end up taking 17 divided by 39, and that is a 44% discount. Make sure you do the difference first. If you don't do the difference, you'll end up with a percentage that is wrong. 33 is from algebra. This is something that was on the TEAS 5 a lot and is kind of coming back to the 6. So again, it will get added back into the curriculum. If you have not seen profit equations, what I want you to deal with in profit equations is revenue minus costs. That's always how we get profit. We take revenue, which could also be worded as income or sales. So what you get for selling a product or putting out a product minus the combined costs. So you can really help yourself on these problems by looking for certain things. You'll notice here there's a flat $200 cost for materials, and it also costs her $1.50 every time she makes a shirt. What that's going to look like is this. You're going to see a parenthesis. So there's only 2 of them that even have parentheses there because you have to combine the costs first. If you don't combine the costs and you take the revenue minus a cost, you get completely skewed numbers. You have to add up all of the costs, then take those from the sales. So we have to add $1.50 Y, and the reason we use Y is because they told us that Y represents a cost. 200 is a flat, so you don't need a Y for 200, you just need 200. But we need to combine the $1.50 per shirt plus the $200 overall. We need a plus sign, and we need a parenthesis to make sure those are getting added so that we have a total cost number before the revenue. The only one that works that has the letters in the right place, and the real dead giveaway on this one is this. You have to add your costs. Once you do that, you want to subtract your costs out of your revenue. So that needs to be a subtraction, and then your X and Y have to be in the same place. So you want to make sure if there are multiple sources of cost, make sure costs are combined. Always make sure that costs are combined. Then make sure that the costs, combined costs, are subtracted out of the sales. Then make sure X and Y are parked correctly. A lot of times you will not get past the first or the second step because there will only be one answer that works. In this instance, if you just remembered that you've got to combine your costs first, you'd have A selected and you'd be moving on. The only other one that even has a parenthesis has them subtracted from each other, which would skew the numbers terribly for that to happen. If you have to get really specific because the answers are all very close to right, then these are the 1, 2, and 3 that would get you there. Again, I will reiterate profit on Mock 6. 34, I'm going to fill in my sides. So I put a 4 there and I put a 12 there. That means that when I did the perimeter, I added 10, 20, 4, 8, 6, and 12, which comes up to 60. As a quick side note, I took D out right away because I noticed that I need to have perimeter, then area, right? So I need to have units, and then I need to have square units. You know before you have any numerical information that perimeter is measured in units, area in square units. That takes D out because they don't have the square units part. That leaves us with A, B, and C. 60 is the perimeter that I get when I add them all up, so that should tell you that it's going to be C. However, I strongly recommend always doing both calculations in case you had a mistake in one of them. Here you would have 10 and 12, and that would be 120. Here you would have 8 and 4, which would be 32. And so if we add together 120 and 32, we're going to get 152 square units. And that is C. Lots of difficult stuff in here. I highly encourage you to try some of those hard ones. Again, you have all the skills that are the framework for those. So really you just need to go back, try it again with the new mentality of how to chain the things together or whatever applies to that problem. If you're still not coming out, hopefully you've got timestamps for the ones that you really wanted to go back and check against my explanation. There will be more of these on Mach 6, so definitely do Mach 6 if that's possible and it's not already in the plans. You will see additional ones there. I save the really hard stuff just for the people who need every dang point. And so you're going to see them in the final versions of the mocks, and that's the only place that you're going to see them. So you can definitely figure out how to change your mind frame for those advanced ones just by watching a few walkthroughs optimally from 5 and 6. But even if you just watch the ones from 5, you can learn how to do those extra conversions on those extra hard problems. I'm going to go back across real quick here. Worst case scenario type problems, and there's all kinds of context that has to surround this. If I was considering how you score Mach 5, I would say you have much more in terms of very hard questions than you maybe normally would. So factoring that in, I would take out, and I don't mean take out from your points, just circle them so you know they were extra advanced. You can count those up and kind of adjust your score a little bit to a normal level. 33 was extra advanced. 29 would be extra advanced because it's a skill we don't cover as much. Let's see. So 33, 29, 24 was pretty hard, which I already had circled. 21 is kind of a little extra hard. It's not super hard, but there was extra info, which makes it a little harder. 18 is considered one of the harder types of questions. I wouldn't be surprised if you see that, but you might not see it along with all these other hard things. 17 would be considered difficult because you had to use an entire flow chart and some extra steps prior to entering the flow chart. All of the rest of that is pretty normal. Certainly 12 was considered pretty hard. 11 was fairly hard, not quite hard enough for me to circle. Definitely 9 and 10 were super advanced. 8 would be considered fairly advanced. And these are all questions that you could see. I never make up questions just to make them harder than the test. But there is a filter that kind of adjusts how many extra hard difficulty level problems you get. So you just couldn't expect maybe to see all of them at once in one test. So none of you that have seen Mock Math 5 are actually going to have a mock or a real math test that's anywhere near this difficulty. The reason being, I took all the worst case scenarios and put them on one test. In reality, you would probably have a third, maybe even a quarter as many really hard questions. So the ones that I would consider sort of giving yourself some points back on as you try to figure out what your score was would be 3, 4, 9, 10, 12, 17, 18, 21, 24, and 29, and 33. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there's 12 of them. 12 of the questions in this one are considered extra hard. I would say another 8 of them are probably considered hard. And what you want to keep in mind is you'll get lots of them that are considered in the easy category that were the first part of the math classes, and you've been good at those for a long time. Several mediums, a couple of hards, and a couple of extra hards. So give yourself back somewhere between 8 and 12 points potentially for this mock if you feel that you didn't necessarily have every skill you needed for the really hard stuff, but now you do. And then hopefully you can see a new score reflected in version 6 where you actually do have an idea of how to do every one of those harder scenarios. So both 5 and 6 are going to score differently. My main focus here is not your score. I don't care what you scored on 5 or 6 at all. It's actually pretty much irrelevant. What I care is that you saw the extra walkthroughs, you did well on all the easies, all the mediums, most of the hards, and now you're developing the skill sets for the extra hard. That's where I would want you to be. It's almost a little bit more intended as a lecture than a mock. So let me know how that came out and let me know why. Let me know what the numbers are. I will keep a record of what the numbers are that are supposed to be advanced. I can help you convert your score. Go back and watch these again, try them again, resolve them. If you absolutely can't figure any of them out, send me a picture of that one and I will send you back the work if it happens to be one that I didn't work out. If I did work it out, you can go back and you can pause and see the exact same work that I would send you. So I'm sure that class was like an hour, hour and a half long. My apologies. Hopefully you got some new skills out of that time. 6, I will definitely aim to make really short. Let me know if I can help additional to what we have done here, and I will see you guys later.